not be able to access anything other than maybe port 80 and port 443 for HTTP and secure HTTP. Thankfully, with OpenID's help, you can not only port scan them behind their firewall, you can port scan them on the loopback interface. A lot of times, services will run on ports that aren't accepting information from the entire network. They're only accepting information from localhost. So in actuality, by doing this, you'll have more access to the computer the server is running on than a computer on its local network would, which is behind the firewall with it. So that's very convenient for an attacker. Then, of course, you can cause a denial of service by causing Jite.com to download, a huge YouTube movie file, or download, Debian install ISOs. It's pretty hard to filter out, all the malicious inputs that can be given to you that are, hundreds of megabytes large. And then again, no one is also saying that those tags, those link tags in the HTML page have to be, in the first kilobyte. They might be after that huge 100 megabyte, YouTube video. So in actuality, you can cause this OpenID enabled website to, download huge websites or to download huge files and essentially cause a denial of service. If it has bandwidth restrictions from the ISP, you can probably conk it offline permanently until they talk to their ISP again. You can also have it contact a host like just a tar pit host, where basically the web server will spawn a new thread and connect to this web server, and it'll ask for the information at CGI bin/hang.pl, but instead the web server will just hang, and it'll just take up a web server thread that's not doing anything. And a single web server thread isn't going to do anything, but it's fairly easy to send 1,000 of these requests, and now you've got 1,000 web server threads that are doing nothing, that each have their own stack and that are taking up precious memory. So you've essentially caused a denial of service in another different way against this host. And then, of course, there's different protocol specifiers: file, FTP, Gopher, Archie, whatever you want. You can specify these and have this OpenID-enabled website possibly perform some sort of malicious operation. When we looked at OpenID libraries and OpenID code, we found that they usually only blocked 2 of these URLs. They blocked protocol specifiers other than HTTP and HTTPS, so the last attack wouldn't work. But they also blocked internal IPs like 192.168.1.15. But they didn't block you from port scanning. They didn't block you from contacting the loopback interface. They didn't block you from causing a denial of service. And that's one of the problems with URLs, is that they're so flexible. Who's to say you don't own NSA.gov? And I mean, who here doesn't? But it's very hard to say who owns what. So I guess the next observation, again, a common security mantra, is that flexibility and security don't get along. And it would be wise for people implementing OpenID-enabled websites to be less flexible and more paranoid and not accept the type of input that they're accepting right now. So after the information has been downloaded and the OpenID server and the OpenID username have been stripped out of that HTML page, the OpenID-enabled website contacts the identity provider directly to negotiate cryptographic keys. The reason cryptography is required is to protect request and response URLs. Other than this communication, the way the OpenID-enabled website and the identity provider talk is by putting information, is by redirecting the user and putting information in the redirect. So without cryptography, it would be very easy for a user to spoof credentials. He could go to jite.com, put in bill.gates.name as his OpenID. He'd be redirected to his identity provider, but instead of filling in the appropriate information, you could just spoof a fake URL back to the OpenID enabled website that says, yeah, you passed authentication, because the only way these two websites are communicating is through the browser redirects. By negotiating cryptographic keys, the OpenID enabled website is sure that the information actually came from the identity provider, because it can be encrypted or signed so that they know it only came from myopenid.com or whatever identity provider they're using, and they're not spoofing that information. So the way this exchange works is that a shared symmetric key is generated using Diffie-Hellman. As you can see in the slide, this is an example HTTP request that would occur in this situation. So Jite.com is contacting myopenid.com. It's basically passing along all the variables that you need for a Diffie-Hellman exchange. And what's the first thing that you as a security professional think of when you think of Diffie-Hellman? Man-in-the-middle attacks, that's right. So Diffie-Hellman is vulnerable to man-in-the-middle attacks. The OpenID specification actually suggests you run Diffie-Hellman over secure HTTP to improve protocol security. The problem is that then there's no reason to use Diffie-Hellman at all during the entire process. If you don't use secure HTTP, you're using Diffie-Hellman and it's vulnerable to man-in-the-middle attacks. If you do use secure HTTP, you have a secure tunnel under a secure tunnel, which makes it redundant. You could just pass around binary strings for the shared symmetric key. So our third observation for OpenID implementers and OpenID implementations is that homebrewed crypto is a no-no. And then instead of rolling your own and trying to do things your way, you should just stick to secure solutions. OpenID implementations should definitely not try to think outside the box.
Okay, I'll take you through the second half. So the next thing is, so you logged into your OpenID site. The OpenID site fetched your URL, right? You fetched Tsyrklevich, that name. It found out who your identity provider is. It contacted the identity provider and established a secure link with it. The next thing that happens is that Jite.com redirects us to myopenid.com for authentication. Okay, that's step number 4. Okay, so you've seen this is before. This is showing that Tsyrklevich.name is associated with a particular identity provider. This identity provider is myopenid.com/server, meaning that when Jite.com fetches this, it knows, okay, in order for Eugene to log in, Eugene needs to go to that URL and enter his credentials. And this is how it looks like. This is a standard HTTP redirect. All it says is, all it says to the browser is, go to this URL. And you notice that the URL itself, myopenid.com/server, is exactly the URL that you see on the screenshot above. So all Jite.com does is it grabs the URL out, and it appends a bunch of parameters to the URL itself. So one of the things that appends is an association handle, and that's a cryptographic, it's basically an HMAC protecting the URL integrity. It provides the identity name, that is my URL, Eugene.Tsyrklevich.name, and it says return to this site, etc. So what's the problem with this? Well, the problem is that Jite.com is controlling who the user is going to be authenticated with, right? Imagine Jite.com is a malicious site. You go to Jite.com, you put in your URL, Eugene.Tsyrklevich.name. But what happens is instead of redirecting me to myopenid.com where I can put in my password, it directs me to myprecious.com. What you probably can't see on the slide is that in the URL, it's no longer myopenid.com, it's myprecious.com. What is myprecious.com? Well, it's a malicious site, right? It's a malicious site which looks identical to myopenid.com, right? You can't tell a difference between myprecious and myopenid, and that's the whole point. The user will not be able to tell, right? The majority of the users cannot even identify the address bar in their browser, let alone the URL that's in that address bar. So in this case, the user will come to myprecious.com, he discloses the password, he says sign in, the password is stolen, and the user is suddenly redirected back to where he was supposed to come, right? So there you go. The whole OpenID-based digital identity is stolen, and the user didn't even realize that there was an attack taking place. So that's called phishing, right? It's a very prevalent attack, and phishing is currently, I would say, number one enemy of the OpenID specification. It is the number one problem that's cited by various people, and it's unfortunately also the problem that has not been completely addressed. There's some talk about putting the security, some locking down just to prevent this problem into the browser itself, into Firefox 3, for example. However, that has not been implemented, and there are no other solutions on the table that can address this problem. So this is still very much outstanding and still very much a problem. Well, the other thing is you can phish not just with malicious OpenID servers, right? So you can go to jai.com, and even jai.com is not malicious, which it's not. You can still get owned. And the way this works is if your host provider, ug.tsyrklevich.name, is malicious, it can simply return the wrong OpenID.server information, right? In this case, whereas before my OpenID.server was my OpenID.com, in this case it's myprecious.com, right? When OpenID sites such as jai.com fetches this information, on bestowing it to the user and to itself, it will going to redirect the user to a malicious site, right? So if you want to attack and steal a bunch of passwords, all you have to do is find a host which hosts a lot of these OpenID URLs. Like, so let's say you want to attack the .name TLD, which hosts, a few 100,000 users, right? You attack their servers, and then you modify the software to return, every time you return OpenID to that server, you replace it with their own URL. And this way you can, steal millions of accounts. So you don't necessarily have to hack jai.com or any other site to attack it. You can just attack the host itself and carry out the same phishing attack. The principle is the same. You're redirecting the user to the wrong URL, or rather to the URL which does unspecified things. Okay, so our next advice to you is to change your bank password again, and the reason for that is we phished the first attempt. Okay, so the next observation is that phishers 1, OpenID 0. Like I said, phishing is a very serious threat to OpenID. There are currently no solutions on the table. Okay, we might see some in the future with Firefox and whatnot, but that's currently not the case. And as I mentioned before, we should not be relying on user education either. You cannot expect little Johnny to understand that myprecious.com is actually malicious and myopenid.com is not. So if you can't read that, that says Moses stop being a cunt. Okay. So next thing is, so you've redirected, you came from jai.com, you came to myopenid.com, right? So this is the screen which shows you, your password field and you're supposed to log in. So what happens? Well, if you remember, there's a little checkbox which says, keep me signed in. And that's very convenient because once you sign into jai.com and then you go to another site, let's say bank.com, you're automatically logged in, right? This is very, very convenient. However, if you think about it the other way, what actually happens is that your identity provider, myopenid.com, sees and processes every single request, right? So you go to jai.com, MyOpenID sees this. You go to bank.com, it sees it again. You go to amazon.com, it sees it again, okay? What does that mean? It means you have no privacy, or rather, you're trusting your identity provider, in this case, myopenid.com, to not do anything with this information, right? So if I was to break into, let's say, myopenid.com, and myopenid.com hosts hundreds of thousands of users, I can simply track them across the internet without doing anything, right? Because the users come to me. The users come to me and say, hey, I want to log into bank.com, or hey, I want to log into amazon.com. So I can track every single user, right? And so OpenID makes privacy difficult. I mean, to be honest with you, it's not just OpenID, right? It's any single sign-on system which aggregates this information will make it difficult. But in case of OpenID, you're actually sending that information onto some other third party, right? It's not something that's hosted in your machine. It's actually out on the internet, right? So you're sending off every single request to someone else. So, well, if you're paranoid, you might say, well, I'm just going to use a separate OpenID login for every site I use, right? Well, that's crazy. I mean, that's not single sign-on anymore. So that's one of the issues that we found is that, OpenID makes privacy difficult.